Hello everyone. Today we will work on the fourth bite of increasing and decreasing function. Okay. Yesterday we did a 7 question in which we did how the function increase or decrease on its domain. Today we will switch on to the next question, that is question number 8. Let's see. This is my question number 8. So I just copied my question from NCERT. So this is question number 8. Now see, read the question number 8. Find the value of x for which the function this is an increasing function. Okay. So we have to show the function is an increasing function. We have to find the value. So let's see, take the function solution with y is equals to, can I write this as x square x minus 2 whole square. So differentiate with respect to x. So this is y dash is equals to, so we applied the u into v rule. So this is first and second function. So x square, derivative of second function is 2x minus 2 plus x minus 2 whole square into 2x. So now x square and x, we get a common. So 2 also common and x minus 2 is also common from this equation. So can I write this as 2 into x minus 2 common from this, and we left with x plus 1, x plus x minus 2. Clear? So this become 2x x minus 2 into 2x minus 2. Now this is 4x x minus 2 x minus 1, because I get common 2 from the above equation. Fine. So we multiply 2 with 2, we get 4. So now from this we have to find the critical points. So we have to draw the critical points on the number line. Clearly from this we get 4 is not equals to 0. So clear, and critical point depend upon the other three factors. So that is let's see, this is for critical points we get 4 not equals to 0, x is equals to 0, x minus 2 equals to 0, x minus 1 equals to 0. Okay, right? So this is x is equals to 2, x is equals to 1. Clear? Now again we have to check the sign. So sign of y dash is equals to 4x x minus 2 x minus 1. Now let's click on the number line. So this is my number line. So this is from minus infinity to positive infinity. So x is 0 somewhere here, 1 somewhere here, and 2 somewhere here. So see very clearly, we get 4 intervals, right? So 4 minus 1 minus 3 minus 2, when we put the number in minus infinity to 0, take any number of your choice, we get a negative here. So for other interval 0 to 1, so when we select the interval thus, we get 4 0.5. Let I put 0.5. So this is 1 minus 1.5, and here it is minus 0.5. So this is positive, thus I get positive. Clear? Now in the next interval, choose any number of your choice. So this is 4, I select 1.5. So 1.5, and this is minus 0.5, this is 0.5, and when we multiply we get negative. Clear? Now in the next interval, select any number, that is 4, 2, 3, right? This is also positive, this is positive. Now clearly the question is, we have to show, no, this is the question, increasing function. We have to show in which interval it is increased. So clearly from number line, see, increase means positive sign. So it is increasing in 0 to 1 and 2 to infinity, right? The question is increasing in the two interval, that is 0 to 1 and 2 to infinity. Very clearly from the number line we get where the function is increased and where the function is decreased. Here now see, I am not show it graphically now to you because the question is to prove or to find the point, not to get the points. Okay, that's why I am just working with the number line only. So from the number line it is proved that the question is increasing in 0 to 1 and 2 to infinity. Fine, this is the difference between today's work and yesterday's work and my previous work. Fine, here we can do with the number line, we can work with the number line only, because from the number line we get the proving solutions, what we have to prove with the questions. Fine, so this is our work. Fine, this is the main difference of this byte, fourth byte with the previous 3 bytes. Fine, in previous 3 byte we draw a graph from each and every question, after each and every question, but here we can show with the number line only in which the function is increase or decrease. Okay, now let's come on the next question, that is question number 9. So this is my question number 9. So I select the question, I copied the question. So this is, read out the question, prove that y is equals to this is an increasing function of theta in 0 to pi by 2, right? So in interval 0 to pi by 2 we have to show that this is increasing function. Again we have to prove. So solution y is 4 sine theta upon 2 plus cos theta minus theta, right? Now now the next step is differentiate with respect to theta, right? Now now y dash is equals to, so u upon v rule we have to apply. So this is 2 cos theta, 2 plus cos theta, 4 cos theta minus 4 sin theta minus sin theta upon 2 plus cos theta whole square, right? Now and derivative of theta is minus 1. Fine, so this is minus 1. Now y dash is equals to 8 cos theta, I multiplied, I opened the bracket, so this is 4 cos square theta plus 4 sin square theta upon 2 plus cos theta whole square, right? And minus 1 as it is. Now y dash is equals to 8 cos theta plus 4 cos square theta plus 4 sin square theta, right? So I get common 4. Fine, 2 plus cos theta whole square as it is, minus 1. Now we know that cos square theta sin square theta is 1. So this is 8 cos theta plus 4, right? So this is 2 plus cos theta whole square minus 1. So y dash is equals to this. Okay, now 1 upon 1 is 1. So when we took an LCM, so this is right, now let's draw a straight line. So this is 2 plus cos theta whole square, right? Now this become 8 cos theta plus 4 minus 2 plus cos theta whole square, right? So this is y dash is equals to 8 cos theta plus 4 as it is. Now I opened the whole square, so this become 4 and this is cos theta square and 4 cos theta. Now I change the sign. Fine, minus and minus. Now this is this. So this is 2 plus cos theta whole square as it is. Fine. So this is plus 4 cancel with minus 4. Now we left with y dash is equals to, now this is 8 cos theta and minus 4 cos theta is 4 cos theta. So this is 4 cos theta minus cos square theta upon 2 plus cos theta whole square, right? So here I get cos theta common, so this is cos theta and 4 minus cos theta as it is upon 2 plus cos theta whole square, right? Fine, this is our full working of I dash. Fine, now here let's check the question. Now in this working we have to show that the function is increasing from 0 to pi by 2. Fine, so look, 2 plus cos theta whole square is always increasing because 0 to pi by 2 we have to check, right? Clearly clear? It is clear from the question. See the questions. Fine. So this is 2 plus cos theta whole square is, so it is 2 plus cos theta whole square is always positive, right? So because whole square is this there, so next is 4 minus cos theta is also always positive. Now from the square we get directly, because a square is always positive, how 4 minus cos theta is positive? Because, so I give you a reason, because cos theta belongs to minus 1 to 1, right? The value of cos theta is always between minus 1 and 1. This is very important reason. So here cos theta is always positive. So when we subtract any value of cos theta from 4, that is always positive. So this value depend upon what? So increasing, decreasing depend upon only at cos theta. Fine. So see, now if this is our interval, this is our interval. So let's check the quadrant. Let's check with the manual value, right? If you put any value like 60 degree, because 60 degree is lying between 0 to pi by 2, 45 degree, 30 degree, you will get always a positive value. So cos theta is always positive from 0 to pi by 2. Clear? So this is the question. We have to prove that the function is increasing in 0 to pi by 2. If you put any value of cos theta in this interval, so you get a positive result. Fine, you get a positive result of this. Hence this is proved. So question is cos theta is positive in 0 to pi by 2. Right, now check the question. So this is positive, and value depend upon cos theta. So cos theta is a positive, having positive value from 0 to pi by 2. So hence it is increasing in 0 to pi by 2. This is our result. Fine, this is our result for this question. This question is also very important question according to the examination point of view. Fine, and now let's switch on to the next question. Now the next question is, they copied the question from the screen. So this is my 10th question. So 10th question is thus: prove that logarithmic function is increasing on 0 to infinity. Fine. Now logarithmic function, function is not given any, so we choose or a function of any of our choice. So solution is fx is equals to log x. I took a function generally log x with base e, because if you take base e, it will cover all type of logarithmic function, because normally log is having base e. When we write log base a, it means that it cover all logarithmic functions. So in this question, firstly we have to change the base change formula. So our fx become what? Now by applying the base changing formula, so fx is equals to log x upon log a. Now here log x is having base e, so this is e. Clear? So this become log x upon log a. Clear? So this is our function. So clearly the function is fx is equals to log x upon log a. Here log x is the function and log a is the constant. So differentiate with respect to x. When we differentiate it with respect to x, we get f dash x is equals to, now 1 by log a is as it is. So here because log a is constant, so this is 1 upon log a as it is, and derivative of log x is 1 by x. Clear? So our f dash x is this. Now we have to find the critical points. Now for the critical points, here the function is increasing. So function is increasing. We have to show that the function is increasing. So it is not mentioned, it is strictly increasing. So increasing is depend upon this 1 upon x. Normally not on 1 upon x, normally on x only, because the fraction is, if I write a fraction 1 by 5, if I write the fraction 1 by 5, so the positivity depend upon 5 only. So if I write minus, the full fraction become minus. So it means that thus denominator is only for positive and negative of the nature, right? So here only x is the playing the main role for the increasing or decreasing. Fine. So it is let it be, it is always positive only if now this is x is positive, right? So x, for x greater than 0, right? If x is greater than 0, full function is greater than 0. Let's draw on a number line. So minus infinity to positive infinity, let 0 is here, and clearly from 0 to infinity it is always positive. It is always positive. So it is increasing in 0 to infinity, right? So this is your question. This is also a very important question, right? In short answer type questions. Fine. So this is increasing in interval 0 to infinity. Fine. Clear? So let's switch on to the next question. Now my next question is, let's switch on to the NCERT. So this is question number 11. I copied the question. Now this is my question. So question number 11th is this. So prove that the function fx is given by this is neither strictly increasing nor decreasing in interval this, right? So here we have to show neither increase or neither decrease, but neither strictly increase or neither strictly decrease. Here also we can prove that. No, clear? So we are not finding any value, we are just proving the question whether this is strictly increasing or decreasing. Let's rub it. Now let's switch on to the solution. So our function is, so solution is equals to our function fx is now this is our function fx, can write it now. Clearly the function is fx is equals to x square minus x, right? Can I write this? So this is fx is equals to x square minus x plus 1 plus 1. Now differentiate with respect to x. So this become f dash x is equals to 2x minus 1, right? So f dash, now for critical point f dash x is equals to 0. So this is 2x minus 1 is equals to 0, 2x is equals to 1, so x is equals to 1 by 2. So critical point is this. So sine of f dash x is equals to 2x minus 1, right? So we have to check the sign. So draw the number line. So this is the number line from minus infinity to positive infinity, right? So minus 1 by 2 is here. So there are two interval, that is minus infinity to 1 by 2. Now see, question is to show increasing in intervals minus 1 to 1. So no need to write minus infinity to infinity, because it is given that the function is, we have to check the function in given interval, that is minus 1 and 1. Clear? So I write the point minus 1 and 1 here, but keep this thing in mind, minus 1 and 1 are not a critical points. These are not a critical points, these are just an interval, just like an infinity, because here it is given that the function we have to check between minus 1 and 1. So our two intervals are from minus 1 to 1 by 2 and from 1 by 2 to 1. Clear this thing? So here concentrate on this concept that minus 1 and 1 are not a critical points. Critical points are always the value of x, and here minus 1 and 1 are in open interval. Open interval means we are not including the extremities. So take any number from minus 1 to 1 by 2. Now this is 0.5. Now this is 0.5. If I want to check the nature of the function, so this is, take it to 0, so this is negative in this, and take another point, let it be, I am taking 0.7 in this, so this is 2, 0.7 minus 1, you can take any point of your choice, I have no issue with that. So this become positive, so hence in the first interval -1 to 1/2 it is negative, and in the second interval it is positive. Fine, clear? So it is neither increase and nor decrease, right? Because for the half interval it increase, for the half interval it decrease. Fine, this is the today's work. Fine, so next 7 questions are your homework, because next 7 questions are very easy and very short answer type questions. So try yourself, and if any problem, comment, right? Thank you.